Hello everyone, Dylan from Elemental Garage. Today we're going to take a look at these engine brackets. So these are brackets for a C10, but the brackets, the machined brackets that came with the suspension and cradle setup weren't working out in this particular build. There was some issue where they were kind of off camber. They were pointed away from each other rather than pointed directly at each other, and they weren't putting the engine at the right negative angle, which was going to put a lot of binding force on the engine mounts. So the shop asked me if I could take a look at the brackets and maybe redesign them to build in the offset angle so that they point towards each other, and then the negative angle so when it's mounted to the engine, it puts the engine at the right tilt. In looking at a cost comparison between machining these one-offs and 3D printing them out of ALSI 10 versus milling in 6061, it actually came out a little bit cheaper to print them when you factored in custom jigs to have to mill in this negative angle that actually goes through the board, not just at the surface. So what we're going to do now is we're going to do a 3D scan of these and compare them to the CAD model to see how close the 3D printing of the ALSI 10 is relative to the Fusion model that we did. So let's go ahead and get started with that. So hopefully if I do this right, you'll be able to see what's going on my screen at the same time that I'm scanning. So I'm going to start. I've got this wedged down with some poster putty, which is just this right here, because we don't want the model to move on the table since it's tracking just the table and not the model. So I can turn this and you can see this doesn't move. So we're going to go ahead and just pick up a scan of this side right here real quick. And we'll spin it around here to make sure we get the back side of it as well. Try and get the different angles inside the bores, because we're going to do a measurement of the bores as well and make sure that those look good here. And then after I get the data on this side, we will pause, we'll flip it over and scan the other side, and then we'll do a merge of the two sides. So I think I've got a pretty good set for this, and let's go ahead and flip it and scan the other side. All right, now we've flipped the model over, or flipped the part over, and we're going to scan the other side, and then we'll merge the two. So let's start. We'll get just a nice side profile here. Make sure we get a good distance, looking for that green light on the tool, which is telling us we're about the right distance to get data. All right, now we're going to just hover over. The way this works is it picks up data best when you're completely perpendicular to the surface that you're scanning. So with something that's got multiple angles, you want to try and get perpendicular to all of them. You can actually move pretty fast. I probably move slower than I need to. So we're trying to get the inside of that bore. So we're going to go around. We're going to get it from multiple angles here. Make sure we get this inside. Try and get these bores as well. We don't have to get all the way through. All right, I think we're looking pretty good here. So I'm going to go ahead and stop this scanning, and then we'll hop over to the computer and do some work on merging the scans. All right, now that we have finished scanning, we're going to clean up the second scan. I already did it on the first, but since we're here, we can just take a look at how this happens in the software. So first thing I'm going to do is stop the scan, and then I'm going to create what's called a clipping plane, which is essentially going to tell it, below X point, cut all this, because this is like the table, this is the turntable, and then here's the part. So we want to be left just with the part. So what's cool is it uses these scanning dots. So I'm going to use these scanning dots as the bottom layer and essentially tell it, hey, anything below these scanning dots, go ahead and get rid of. So anything you see that's red, it's going to get rid of. Now you can see here, it's going to cut just a little bit of the bottom of the part off, but that's okay because we've got that data from the other side of the scan. So I can lower, oops, let's see. Can make this, 0.9. It's going to take 0.9 millimeters off the bottom. So we're going to go ahead and create that. And it's going to cut all that stuff away. Now we've got a little bit of noise out here. So this is easy. I can just click this and say, hey, anything that's not that or touching that, highlight, and we are going to delete. So we're going to go ahead and do that. Okay, so cool. So now we've got both sides. We've got the first side and then the second side, and now we need to align these together before we merge the scans. So what we're going to do is we're going to do what's called a surface alignment. Now this is a new UI here, so I'm still learning. Okay, surface best fit. And excuse me, what we're going to do is we're going to do a little manual, and it's going to give us two screens. And what we want to do is I like to orient both these screens kind of similarly. So the part is laid out the same way. And then what I'm going to do is I'm just going to start clicking, and I'm going to say, you know what, that point's about that point. And this point is about this point. And this point here is about equal to this point here, and it's going to start overlaying the parts on top of each other. And when it's close, what I'm going to do is say best fit, and it's going to do the rest of the math, and it's going to overlay the parts on top of each other. And you can see how these two colors are kind of blending. It's showing you that this is the amount of overlap, like how close these two models are to each other. So then I'm going to hit OK. And now we have these two scans that are overlaid on each other. And then what I'm going to do is I'm going to merge these two scans together. So scan 1 and scan 2. I'm going to keep the original scans just in case I want to do something with them. And we can remove a couple isolated patches. And then I'm going to hit accept. And, don't mean to make this like a super long video, going through all the detail, but it's kind of interesting to see. So if I turn off scan 1, scan 2, and let's see, let's turn off the positioning targets. Now we have a two-sided model of our part. And as you can see, there's some missing data on the inside because the laser, and the camera couldn't see all the way down in there. We got really good on the bore. But that's okay. We can tell it at a later time to fill this in right here if we need to. So what we're going to do next is, now that we have this scan, we're going to bring in the CAD model that I designed, and we're going to overlay that with this part and see how close to our CAD model the scan got. So stay tuned. We'll hop over to that next. All right, now we are going to just take a quick look at in the inspection module here and see how close we are looking. So here's the 3D scan that we took. Now, if I turn that off, we can take a look at, here is the CAD model from Fusion that the 3D print was based on. And if I overlay the two of them, you can see, how close they are meshed together. And then if we want to take a look, we can look at a color map here. So this color map is, plus or minus 3.1 millimeters. But anything that is green is plus or minus half a millimeter. And then anything yellow is starting to be a little bit larger than was. So overall, this is pretty awesome. I mean, as you can see, if I turn off the CAD for a second, nearly everything on here is within half a millimeter of spec. You have a little bit of deviation up here in this boss and bore, that's deviating a little bit more than the half a millimeter, but overall pretty darn good for a 3D print. Now, just as a point of reference, again, we 3D printed these because these are just one-offs to correct an issue that we were seeing in some geometry on another vendor's kit. If I was making 5 of these or 10 of these, it would be more economical to CNC these, because for the most part these are 3-axis friendly CNC. If we look at the let's take a look at the CAD model here real quick. The reason why we opted to 3D print these is mainly because this bore up here is not only at an angle on the surface, but it's also an angle going through the bore. So there's 2 ways you could do that. You could do some surface milling where you bore as much as you can see on one side and then bore the other side, and do some 3D contouring with like a ball end mill. But when you factor in the time to do those extra setups, or to build a jig where you can set this at an angle, an offset angle, so you can flat mill the top of this, it came out to be more expensive actually than 3D printing these. So knowing that we were going to 3D print these, what we did is, added some reinforcement, made these walls just a little bit thicker because the actual mounting would allow for that extra space, just to beef them up a little bit. So overall, pretty happy with these. Again, looking at the color map, we can see that they're pretty bang on for what's needed. Now, granted, if this was like, internal engine tolerances, wouldn't be good enough. We're talking about an engine mount here. I mean, we've got, millimeters and eighths of inches to play with. So having anything that's half a millimeter is pretty great. So yeah, we're going to deliver these to the customer next, and see how they work. All right. Well, thanks for watching this. If you have any questions, just hit us up. We're at Elemental Garage on Instagram. Build it at elementalgarage.com is our email, and elementalgarage.com is our website. So come say hi, reach out, message us. You can find our phone number on our website. Give us a call if you need anything scanned, designed, inspected, CNC'd. Always looking for our next project. So thank you much. Have a great day.